Good day, everyone. I am Mark Wilfred Guingguing, and I am one of the members of the group 5 that will be talking about structural design of railways and pavement. So, kanina topic is muna siyang gitunga-tunga para sa mga members, and ako ang magsugod for of course, the introduction of railway structure. So, let's begin and ilailahan natin na sila. No? Let's go. So, railway structures. A railway structure encompasses a wide array of construction intended to support the track itself or house railway operation. So, when we say railway structure, it refers to the physical components that make up a railway system. It includes tracks, bridges, uh, tunnels, stations, signals, and other elements that allows trains to move safely from one place to another. Think of it like the skeleton of a train system. The tracks provide the path for the trains, while bridges and tunnels uh, help them get over, or through obstacles. So stations are like the train's resting spots where passengers get on or off, and signals are like traffic lights for trains, guiding them to on when it's safe to proceed. So, in simple terms, railway structure is a set of things that make train travel possible and organized. So, what is a bridge deck? A bridge deck is a portion of a railway bridge that supplies a means of carrying the track rails. So when we say a bridge deck in a railway track, it is like the train's pathway when it goes over a bridge. It's like the surface that supports the train tracks, allowing trains to safely cross things like rivers or gaps in the land. Imagine a train traveling on a strong structure over a river. The part where the tracks sit is the bridge deck. The deck needs to be really sturdy to handle the weight of the train and the forces it creates. So, depending on the bridge, the deck can be made of materials like concrete or steel. So, when a train is going over a bridge, it's moving on a bridge deck. So as you can see here in this visual representation, we have an example of a ballast track. So a ballast track contains a ballast section on the track, on the railway. So as you can see here, this is the rail. Wait, so this is the rail. This is the steeper. This is the ballast section, or where rocks are located. So we'll be talking about this later, but first let's focus on what is a bridge deck first. So this is a bridge deck, the one that carries the weight of this railway. So that is a bridge deck. So basically, there are two general types of bridge deck. The first one is the open bridge deck. The rails are anchored directly to timber bridge ties supported directly on the floor system of the superstructure. The second one is the ballasted bridge. The rails are anchored directly to timber track ties supported on the ballast section. So let's uh, explain them one by one. So let's first talk about open bridge deck. So an open bridge deck is like a big, strong platform held by supports, and it's used to help things like roads or trains cross over something like river, valley, or other road. The word open means that it doesn't have a roof or walls. It's more like wide and sturdy floor that lets you see through. So the openness of the bridge means it doesn't have roof or walls, as you can see here in this illustration, making it lighter and allowing wind to pass through. So this design helps keep the bridge steady and safe. So in simple terms, an open bridge is like strong and elevated road or track that helps people and vehicles go from one side to the other without any trouble. So the openings in the deck also allow for better ventilation, which can be important for certain types of bridges or for managing heat generated by drains. So the second type of bridge deck is the ballasted deck. So the timber track ties, also known as sleepers or cross ties, are horizontal supports that hold the rails in place. So these ties are placed on a layer of ballast, which is a material like crushed stone or gravel. So a ballasted bridge is like a strong and stable pathway that goes over something like a river on a road. It's made with a special kind of rocks or stones called ballast. These rocks are placed on a bridge to provide support and stability. So unlike sa open bridge deck, ang ballasted deck is supported by ballast. Like with the help of these rocks, the bridge is stable and sturdy. So, ang katong ganina is wala na to. Dito na siya siyang support. While kaning ballast and deck is na pa siya layers of ballast, which is a material like crushed stone, as you can see here. So, muna siya ang ballasted deck, no? Na siya kaning gravel, which used as support para mas stable ang railway, especially pag bridge na siya ng tabok-tab rivers and other. Uh, so, speaking of ballast, para mas masabtan pa ninyo what is a ballast, unsay purpose niya, unsay reason nganong kana man siya ito makita sa railway or sa rail or sa track. So, the purpose of ballast in a railway track is to provide stability, as what I've said earlier. Uh, Also, it helps to drain water and support for the tracks. Ballast is a layer of coarse, angular stones or gravel that is placed on the roadbed. So, what's the purpose of ballast? So, natay four diri akong gibutang no four. So, first is stability. So, stability. Why? So, ballast helps distribute the load of the train and its cargo evenly across the underlying soil. This distribution of weight prevents the tracks from sinking into the ground and providing stability to the railway track. No? So, it helps distribute the load of the train evenly sa katong uh, railway across the underlying soil. Across the underlying soil. The second one is drainage. So ballast allows for proper drainage of water away from the tracks. The open spaces between the stones permit water to flow through, preventing the accumulation of water that could otherwise weaken the track structure and cause erosion. So if mabantayan na to, ang ballast, as you can see here, is kanang because of its angular shape, dili siya ingon nga uh, magtapok ra nga dili pwede makaagi ang water. As you can see here, we can see ang angular shape. If nanay tubig dira mo dito na siya drain sa ilalom, dili na makaingon nga magpundo ang tubig dira and then mo'y maka-cause og kanang instability sa railway. So mayo siya sa when it comes to draining water kay because of its angular shape, no? The open spaces niya dili siya makastore og water dira. So the third one is track support. So mo yung pinaka main purpose na. So ballast provides a firm and level surface for the tracks. It helps to anchor the tracks in place, preventing lateral or horizontal movement. So this support is crucial for maintaining the alignment and course of the tracks, ensuring safe and smooth train operations. So, auto siya, it supports the track. Supports with, it helps with the stability of the rail track and parang dili siya ano, horizontal movement or prevent lateral movement. So the last one, the fourth and the last one is the latter reduction of vibration and noise. Reduction of vibration and noise. So ballast absorbs some of the vibrations produced by moving trains, reducing the transmission of these vibrations to the surrounding environment. This helps minimize noise and ensures a smoother ride for passengers and cargo. So mo pa na siya ay one of the purpose nga no ballast ang gamit kaya it reduce the vibration and noise. So after atong four ka purpose nga ng ballast ang gigamit, napod ay four ka reasons. The first one is angular shape. So ballast stones are typically angular shape rather than rounded. So as you can see here, wala dyan kayo makita ang rounded ballast. Puro gina siya angular shape. So this angular shape helps the stones interlock with each other, creating a stable and compact layer that resists movement. So this is crucial for maintaining the alignment and stability of the tracks. So as what I've said earlier, dito sa purpose nga ng ballast man is, ako na-mention ito is, because of its angular shape, ma-drain dayon ang water. But here, it also states that ang angular shape is makahelp sa stability sa railway. Kaya because of its angular shape, ma-interlock ang mga rocks, no? Helps the stones interlock with each other, and that causes to create a stable and compact layer that resists movement. So the next reason is uniform in size. So as you can see here, no, dito gyud ako ilang gap sa ilang mga sizes mo. Doon ra po lang sila kadakam sila kagabihan. So ballast is usually specified to have relatively uniform size, which contributes to the stability of the track structure. So the consistent size helps distribute the load evenly and prevent the larger stones from settling into the gaps between the smaller ones. So because of its uniform size, uniform pod ang stability, I mean uniform pod ang katong load nga iyang sa tawag na ma-distribute, no? So the consistent size help distribute the load evenly. So motong dili stable ang imong railway because of that uniform distribution of load. So the third reason is the high density. So ballast materials are often dense, providing significant mass in a confined space. So this density contributes to the overall stability of the track and helps resist deformation under the weight and dynamic forces exerted by passing trains. So the last one is resistance to weathering. So balik-balik na no. So resistance to weathering. Ballast stones are chosen for their resistance to weathering and erosion. So they need to withstand the effects of rain, wind, and the temperature changes without breaking down excessively. So this durability ensures the long-term stability of the track bed. So, di ba? Sa kadaghang rocks nga nung ballast pa man yung kipili, di ba? Because of this purpose and reasons. So while other rocks may have some of these characteristics, ballast is specifically chosen and engineered to meet the unique requirements of railway tracks, providing stable, durable, and maintainable foundation for the rail infrastructure. Now let's proceed to structural design. So what is a structural design? It is the methodological investigation of the stability, strength, and rigidity of structures. So the basic objective in structural analysis and design is to produce a structure capable of resisting all applied loads without failure during its intended life. So as structural design is the thoughtful and meticulous process of developing plans for buildings and other constructions. So ensuring they are not just aesthetically pleasing, but more importantly, stable siya and secure siya. So it begins with a thorough understanding of unsay purpose aning na structure. Pang residential ba ni siya, pang bridge ba ni siya, or skyscraper. So engineers carefully select materials like concrete, steel, or wood based on their properties and sustainability for the project. So the design process involves calculating and distributing loads, considering factors such as the weight of the structure, environmental conditions, and potential stresses. So, safety factors are incorporated to provide a margin of safety, guarding against unforeseen circumstances. So, the result is a comprehensive set of plans and specifications that guide builders in constructing a structure that is not only functional and efficient but also capable po siya to withstand the various forces nga ma-encounter throughout its lifespan. So there are three phases that structural design contain, no? So first is planning, the second one is design, and the third one is the construction. So in planning phase, this phase involves consideration of the various requirements and factors affecting the general layout and dimensions of the structure and results in the choice of one or perhaps several alternative types of structure which offer the best general solution. So during this phase, engineers and architects carefully consider various requirements and factors that can influence the overall layout and dimension of the structure. So these factors may include the intended use of the structure, the site conditions, budget, constraints, and static consideration. So basically, the planning phase in the structural design process is like the brainstorming stage where engineers and architects figure out what the building or structure needs to do and unsay dapat itsura niya. It's a bit like deciding the blueprint before building something. So in this phase, they ask questions like, uh, para asa man nga building, sa may gamit ani na building, pila man ka tawo ang magamit ani, pila man ka tawo ang magamit mosulod or mo ang weight, pila man ka tawo. So unsa nga materials ang dapat gamiton, kahoy ba, steel ba, or concrete. So they also consider things like the surroundings and the weather in that area. So the goal of planning phase is to explore different alternatives and ultimately choose one or possibly a few types of structures that offer the best general solution to meet the project's objectives. So this phase is like the initial brainstorming and decision making stage where the team outlines the broad concepts and possibilities before moving on to the more detailed design and construction phases. The second phase is the design phase. So this phase involves a detailed consideration for the alternative solutions defined in the planning phase and results in the determination of the most suitable proportions, dimensions, and details of the structural elements and connections for constructing each alternative structural arrangement being considered. So in this phase, our engineers and architects carefully think about the sizes, shapes, specific details of every part of the structure, like beams, columns, and connections between them. It's a bit like deciding the exact pieces and measurements needed to build something strong and safe. So the design phase in the structural design is like drawing the detailed plans for building a structure such as a house or a bridge. So imagine you're designing a puzzle. You need to figure out all the pieces fit together to make a strong and stable picture. So in the design phase, engineers and architects use math and science to decide unsang materials o shapes para aning nga structure. I-calculate nila how much weight ang kinahanglan, uh, it needs how much weight it needs to hold, like people, furnitures, or vehicles, cars, and think about saan nila pag stand sa mga weather, environmental ng mga loads like wind or earthquakes. So the last phase for this structural design is the construction. So this phase involves mobilization of personnel, procurement of materials and equipment, including their transportation to the site, and actual on-site erection. So the construction phase indeed involves the mobilization of personnel, like the workers involved in structure, in construction, of course. So the procurement of materials and equipment, including their transportation to the construction site, and the actual on-site erection or assembly of the structure. So this phase is where the plans developed during the design phase come to life. And the construction team works to build the structure and build a structure according to the specified guidelines and detailed plans. So builders follows the detailed plans and instructions created during the design phase, using materials like concrete, steel, or wood to put everything together. So it's like turning the design on paper into physical, real-life structure. So during construction, of course, workers make sure everything is put in the right place and follows the plan to make the structure strong, safe, and ready to be used. Sa railway structure, napunay siya yung mga uh, parameters. So the geometric design of a railway track involves various parameters that affect the track's shape and layout. So, unsa din ang parameters di ay? So, in simple terms, in simple terms, a parameter is like a special detail or condition that you consider when dealing with something. It's a factor or characteristic that helps define or understand the situation. So, diba? So, example, if you're baking a cake or cookies, so the amount of sugar you use is a parameter because it affects how sweet the cookies will be. So, in more technical context, like in science or engineering, parameters are specific values or consideration that can influence how things work or behave. They are like the important pieces of information you need to know about something. So, mo to siya ang parameter. So, here are some key parameters no, in a railway track. So, first is alignment. Second is super elevation or banking. Cross level or cant. Radius of curvature, clearance, vertical clearances, and gradient. So, ito na siyang isa-isahon o discuss para mas masabtan. Ito siya. So, alignment. Alignment is like the path that track follows. It includes straight sections and curves. Engineers decide how much of the track should be straight and where to put curves based on factors like the landscape and the train speed. So, of course, sa alignment, dili na ka magpataka-taka og butang og curve dira, no? Kay pataka mo og curve dira. Of course, ang dagan sa train is madaot, and that will cause a major accident or sa panadara. So good alignment ensures that the track follows a smooth and safe path, avoiding sudden turns or twists. So bad alignment could make the ride uncomfortable for passengers, cause wear on the tracks, and affect the train's stability. So super elevation or banking. This is a tilt given to the outer edge of a track in a curve, like a bank road, so it helps trains go around curves more smoothly without tipping over. So banking helps trains smoothly navigate curves. So without the super elevation or the banking, trains might experience more friction on curves, leading to wear on wheels and trucks, and potential safety issues. So cross level or cut. So cross level refers to the difference in height between the two rails. It helps balance the track on curves and ensures a level surface for the train. So as you can see in the visual representation below, it shows a cross level measurement. Like dira i-measure para mahibawan if ang two rails kay balance siya for the train's safety. So cross level ensures that the track are level horizontally. Without it, one rail might be higher than the other, causing an uneven surface that could affect the train's stability and safety. The next is the radius of curvature. This is about how tight or gradual a curve is. Larger radii are more gradual curves, while smaller radii are tighter curves. So larger radii create smoother, more comfortable curves. The tight curves could cause discomfort for passengers and increase wear on wheels and trucks. So if atong imaginon nga mas gamay, mas tight ang kuan, ang what you call this, tight ang curve, di ba mas lisod ay kanang mas hadlok siya nga mukalit ra ka og kanang liko, no? And that will cause wear sa wheels. And then pag dako na, like larger radii, mas dako nga curve is mas smooth na siya, mas safe siya nga kanang agian, no? Kaysa sa mga tight nga curves. Next is the clearance. So clearance is the space around the tracks. It ensures there's enough room for trains to pass each other safely and for other structures like bridges or platforms. So muna siya ang kanang clearance. Of course, dapat kanang ang giagian sa atong trains kay kanang dili guot, like naray safe ay naray space para if ever na magtagbo dili ra magkaunsa, dili ra magbangga unsa pa nitra or other ba like bridges or unsa pa nga platform. So dapat na ay sakto nga space, no? Clearance, that's the clearance. So proper clearance ensures there's enough space around the tracks for trains to pass each other safely. So insufficient clearance could result in collision or disruptions, of course. So if katong ganina is clearance lang ang giingon, karon na pod is na vertical clearance, so murag i-specify na siya, no? So this involves ensuring there's enough space above and below the track for things like tunnels and overhead structures. So katong ganina is like more on like horizontal clearance, no? While diri is vertical clearance. So as you can see in the figure below, more tunnel, no? Dapat na enough space for trains to pass safely. So ensuring enough space above and below the tracks prevents collision with structures like tunnels and bridges. So insufficient vertical clearances could damage trains and structures. So the last one is the gradient. So a gradient is the slope of the track. So if you've ever walked up or down a hill, you know what a slope is. Similarly, tracks can go uphill, called an ascending gradient, downhill, descending gradient, or stay level. So in a railway track, a gradient is refers to the slope or the incline of the track. So determining the whether they go uphill, or it is called or another term, rising gradient, or downhill, in other term, falling gradient. So gradient are crucial for the efficiency, safety, and cost effectiveness of train travel. So ensuring that the energy demands are balanced and that trains can navigate changes in elevation in a controlled manner. So para mas masabtan pa nato sa gradient, let's dig deeper back. So this one. So kani siya kani mga gradient mo siya gradient post, no? So gradient post mo siya makita. So one in 454, one in 715, level 1 in 417. So let's proceed sa para mas i-explain pa na siya. So A rising gradient is one in which the track rises in the direction of the movement of traffic, and a down or falling gradient is one in which the track loses elevation in the direction of movement of traffic. So when we say a rising gradient on a railway means that the tracks are going uphill. So it's like when you're walking or driving up a hill. So you're going against the force of gravity. For example, if a train is moving from a lower point to a higher point on the tracks, it's going up a rising gradient. So a falling gradient, on the other hand, means that the tracks are going downhill. It's the opposite of rising. So in this case, the tracks slope downward, helping the train move with the force of gravity. So if a train is moving from a higher point to a lower point, it's going down on a falling gradient. So a gradient is normally represented by the distance traveled for a rise or fall of one unit. Sometimes the gradient is indicated as percent rise or fall. For example, if there is a rise of 1 meter in 400, the gradient is 0.25%. Okay, so para mas masabtan pa dyan nato, unsa dyan ang like, gradient, like katong ipangbutang sa mga gradient pose. So if we're given 1 in 400, like let's assume na lang of in meters na siya. So 1 meter in 400 meters, ang pasabot ana kay in 400 meters ni mga run, napa na siya rising gradient nga 1 meter. So 400 meters run, nagsaka siya o 1 meter. And then sa 1 on falling gradient, what siya rising gradient? It's a falling gradient, 1 on 400, same mo siya pero paubos. Like in 400 ni mga meters nga run, nakay 400 meter, ay 1 meter nga fall. So 400 meters nga run, nakay 1 meter nga fall. So that is 1 on 400 meters sa falling gradient or 0.25%. So why gradients are important? So gradients are provided to meet the following objectives. So the first is to reach various stations at different elevations, to follow the natural contours of the ground to the extent possible, to reduce the cost of earth. So the purpose of these gradients is to facilitate the movement of trains over varying elevations. So when the tracks ascend or have a rising gradient, trains face an uphill climb and require additional power to reach higher points. So conversely, when the tracks descend or have a falling gradient, trains can cause downhill with their assistance of gravity, requiring less energy. So in summary, uh, rising gradients go up like a hill and falling gradients go down. So these gradients are important for train operations as they affect how much effort and energy the train needs to move and control its speed. So engineers carefully plan and design gradients to optimize train performance and efficiency on different sections of the railway.
Good day, everyone. So today, I will continue to report about structural design of railways and pavements. Since many report design of railways or railway design, so ang report na pod nako is about pavement design. So what is pavement design? So pavement design is a highway pavement, a structure consisting of superimposed layers of processed materials above the natural subsoil soil subgrade, whose primary function is to distribute the applied vehicle loads to the subgrade. So, unsa man jud ng pavement? First, so pavement kay mao ni siya ang dalan jud or agianan jud sa mga sakyanan. So a pavement is the part of the road that carries the traffic, not to be confused with the footpath, and has a set of layers or materials placed over the natural ground, which is the subgrade. The pavement layer spread the load of the vehicle so that it does not exceed the strength capacity of the subgrade. So, mao ni siya ang pavement. Ano, agianan jud sa mga vehicles. So, mao ni siya ang layers sa pavement. So, di ba, mao ni ang subgrade sa kinaubsan, which is the existing soil, and then sub-base course, optional learn ni siya nga layer, and then sunod kay kaning base course, non-erosive, and then ang last nga layer kay mao na ang concrete slab. So, requirements of a pavement. So, our requirements of a pavement kay una, sufficient thickness to distribute the wheel load stresses to a safe value on the subgrade soil. And the next is structurally strong to withstand all types of stresses imposed to it. And the next is adequate coefficient of friction to prevent skidding of vehicles. And then fourth, a smooth surface to provide comfort to road users even at high speed. And the next is produce least noise from moving vehicles. The next is dust-proof surface so that traffic safety is not impaired by reducing visibility. So, i-make sure jud nila na ang pavement hay wala kaayo siya dust para dili siya makatabon sa mga samin or sa kanang windshield sa mga sakyanan. And the next is impervious surface so that the subgrade soil is well protected and long design life with low maintenance cost. So, mao ni siya ang mga requirements sa isa ka pavement. So, soil engineering for highway design. So, here siya is the basic characteristics of a soil may be described in terms of its origin, formation, grade size, and shape. So, dili pud sila, di ba, the professionals, ako sa in construction, dili pud sila basta-basta or bisag asa man lang mo gama og pavement. So, dapat naa jud siya standard sa soil nga ilang butngan or ilang itest daan before nila i-construct ang pavement. Before i-construct ang pavement. Una is ang soil characteristics. So, sa soil characteristics, ilang ilang ino or ilang hibaw ng origin and formation of soils. So, actually, ang mubuhat jud ani sa ang soil engineering kay usually kay mga geotechnical engineers. So before i-construct ang pavement, i-check sa sila daan sa mga geotechnical engineers, sila ang mo-search o mo-survey sa soil kung asa i-construct ang pavement. So mao ni lang gina-consider una sa soil characteristics sa ilang origin and formation of soils. And then sunod kay ang surface texture. Dapat it's either fine texture soils, which are soils consisting mainly of silts and clays with very small particle sizes, and then, or coarse textured soils, soils consisting mainly of sand and gravel with larger particles. And the next kay properties of soil. So again, ang most survey ani kay ang mga geotechnical engineers. Pero ang ilang i-survey sa properties of soil ay sa characteristics sa soil, kaduha kay properties of soil. Una is the phase relations. Relations or soil is considered three-phase system consists of air, water, and solids. Diba? Under aning phase relations Or porosity. Porosity is the ratio of the volume of voids to the total volume of the soil. So, mo ni siya ang formula kanang nasa yung kilid, which is N equals V sub V over V. And then next, sa phase relations kay void ratio, the ratio of the volume of voids to the volume of solids. So, mo po niya formula kanina sa kilid, which is E equals V sub V over V sub S. Next is the moisture content. So, the quantity of water in soil mass. So, mo po na yung formula. And then the degree of saturation. So, the degree of saturation is a percentage of void space occupied by water. And then next is the dry density, which is the density of the soil with the water removed. And then next is submerged density. Density of the soil which water is different saturated density. So I'm going to say submerged density. Next, our last second topic is the Atterberg limits. So the water content levels at which the soil changes from one state to the other are the Atterberg limits. So kaning Atterberg limits kay gina-consider na siya sa mga geotechnical engineers kung unsa ray limit limit sa soil if mag-change siya og state. For example, mag-ulan. So, di ba, ang dry na soil, if mag-ulan, usually, kay mabasa dyan na siya. So, inigbasa niya, kay ma-change na yung state. Mahimo na siyang semi-liquid, baka ha. So, i-measure sa mga geotechnical engineers kung unsa ang limits. And if makapaserve ba sa limits ang kato nga certain nga soil area nga tukudan sa pavement. So, una is the shrinkage limit. When a saturated soil is slowly dried, the volume shrinks, but the soil continues to contain moisture. And the next is the plastic limit. So the moisture content at which the soil crumbles when it is rolled down to a diameter of 1/8 of an inch. And lastly, the liquid limit, which is the moisture content at which the soil will flow and close a groove of 1/2 inch within it after the standard liquid limit equipment has been dropped 25 pounds. So, kailangan jud i-test yun nila ang mga Atterberg limits if magama og pavement sa pavement design para ma-make sure na safe siya once na ma-construct ang pavement. And kay, di ba, sa before, naka-first, kay dapat i-make sure jud nila na low maintenance siya in the long run and dugay siya maguba. So, that will be my report. Thank you for listening.
For the continuation of the topic, I'll be discussing about the soil surveys for highways construction. So, soil surveys entail the investigation of the soil characteristics on the highways route and identification of suitable soils for use as sub-base and fill materials. So, soil surveys naghatag na siya og important role in highways constructions as they involve the investigation of soil characteristics along the proposed highways routes. These surveys are essential for identifying suitable soils that can be used or utilized as sub-base and fill materials in the construction processes. The careful selection of appropriate soils ensures our structural integrity, the stability of the infrastructures, and the longevity of the highways. So, ang aim ani kay mag-provide ni siya og significance sa soil surveys for highways constructions. Nag-highlight ko ni siya og better understanding of soil properties and their implications on the overall projects. Next, we have geophysical methods of soil exploration. So, geophysical methods play a crucial role in soil exploration. Enable ni siya sa mga researchers to gain valuable insights into soil profiles and their characteristics. So, natay two commonly employed techniques in the field of geophysical soil exploration. First is the resistivity method. This is based on the difference in electrical conductivity or resistivity of different types of soils. So, kini nga method use ni siya sa mga geophysics and environmental studies for mapping subsurface variations in soil type and geological institute. The resistivity method is widely used in geophysics and environmental studies for mapping subsurface variations in soil type, moisture content, and geological structures. By electrical resistance of the ground, by measuring the electrical resistance, kini nga method naghatag po ni siya tabang sa mga insights in other characteristics of the subsurface, such as ang presence sa groundwater, ang depth sa bedrock, o ang extent of the mineral deposits. So next method is the seismic method. It is used to identify the location of the rock profiles or dense strata underlying softer materials. So, kini nga method is a powerful geological tool na magamit para maka-identify para ma-locate ang mga rock profiles o ang dense strata na lie beneath softer materials. It provides valuable insights in the subsurface structure. It helps the geologists and the other researchers to properly understand the composition, depth, and spatial distribution of the geological formations. By analyzing and interpreting seismic data, scientists can gain a better understanding of various subsurface features such as oil and gas reservoir, geological faults, and underground water resources. So, kini pod nga method, magamit po na siya sa mga geophysics and other exploration industries. O naghatag og fundamental rules in supporting crucial decision making and processes related to the resource extractions and infrastructure development and disaster risk assessment. So next is the soil compaction. When soil is to be used as embankment or sub-base material in highways construction, it is essential that the material be placed in uniform layers and compacted to a high density. So kini nga aspect sa highways constructions, particularly in utilizing soil as embankment or sub-base material, the kini nga process nag-involve ni siya og placement of soil in uniform layers and subsequent compaction to achieve a high level of density. It also ensures that the stability and durability of the road, as well as the prevention of settlement or deformation over time. Ang importance ani para ma-achieve ang high density compaction are cannot be overstated, as inadequate compaction can lead to various issues, including settlement, rotting, cracking, and eventually pavement failure. Compacted soil provides solid foundations for the road, extending its lifespan, minimizing maintenance cost, and also it ensures a safe and smooth driving experience for our motorists. Through a proper compaction techniques, so ang proper nga techniques sa soil compactions kay nag-provide og improving the load bearing capacity and also the stability. By implementing these effective compaction practices, highways can be constructed with a durable and long-lasting foundation. It also ensures optical performance and safety for our motorists and users. Next is the special soil test for pavement design. The results obtained from this test are used individually in the design of some pavements depending on the pavement design method used. Kini na test nag-providing valuable insights into the characteristics and behavior of the underlying soil. These tests yield specific data that are utilized individually in the pavement design processes. With the ability to assess ang key factors sa pavement performance such as soil strength, compaction, and moisture content, this specialized test empowerment engineers to make informed decisions when it comes to designing pavements that can also withstand the anticipated traffic loads and environmental conditions. By incorporating the results obtained from this test into a pavement design process, we can optimize the performance and also the safety of the road infrastructures. The significance of special soil test for pavement design into a specific ways in which the result of this test influence pavement design methods. Next, we have flexible pavement. It will transmit wheel load stresses to the lower layers by grain-to-grain transfers through the points of contact in the granular structure. So, flexible pavements refers to a type of roadway constructions that is designed to transmit wheel load stresses to lower layers through grain-to-grain transfers. So unlike sa other pavements that rely on the continuous slab, ang flexible pavements kay nag-distribute ni siya og load-bearing capacity through the granular structure of the road. So ito nga granular structure mo nag-enable sa pavement to flex and adapt to change the temperature and traffic conditions, ensuring the better durability and longevity. So for better understanding sa flexible pavement, natay different types of flexible pavements. First is the conventional layered flexible pavement. It is a layered systems with high quality expensive material are placed on top where stresses are high and low quality cheap materials are placed in lower layer. In road construction, conventional layered flexible pavements have long been go-to approach. These pavements are designed as layered systems with primary objectives of optimizing performance and durability. The concept behind these pavements involves strategically placing high-quality, expensive materials on the top layer where the stresses are highest, while also using low-quality and expensive materials for lower layers. This design strategy aims to strike a balance between cost effectiveness and structural integrity. So next type of pavements is fold-damp asphalt pavement, are constructed by placing bituminous layers directly on the soil subgrade. This more suitable when there is a high traffic and local materials are not available. Asphalt pavement is commonly used material for constructing roads. It also offers high durability, flexibility, and cost effectiveness. In a certain scenarios where high traffic volumes are expected and local constructed materials are scarce, and the alternative method called fold-depth asphalt pavement can be employed. So in this approach, bituminous layers are directly placed on the soil subgrade by passing the need for granular based or sub-base layers. This concept of fold-damp asphalt pavements, nag-highlight ni siya og mga advantages like suitable for high traffic areas, and also it is relevant in the absence of adequate local materials. The last type of flexible pavements is contained rock asphalt. It is a modified dense graded asphalt concrete is placed above subgrade. It is significantly reduce the vertical compressive strain on soil subgrade and protect from surface water. So contained rock asphalt is it is a composite pavement structures that also consist of a layer of open graded aggregate sandwiched between two layers of asphalt. It is designed to enhance the performance and longevity of a roadway by reducing vertical compressive strain on the soil subgrade and protecting it from surface water. The use of modified dense graded asphalt concrete on top of the subgrade further enhances the structural integrity of the pavement system. So it also aims to explore the benefits and application of road construction. It's also have advantages in reducing soil strain, improving drainage, and enhancing overall pavement durability. So in this process, we will address the construction process and also the material properties, and also it is the best practices associated with utilizing for infrastructure development. So we also have typical layers of flexible pavement. First layer is called cell coat. It is a thin surface treatment used to waterproof the surface and to provide skid resistance. So cell coat is commonly used in thin surface treatment. It is serve the dual purpose of waterproofing the underlying surface and also enhancing skid resistance. This protective layer is applied to various surfaces including roads, driveways, parking lots, and pathways. So napo tayo ginatawag na layer na tack coat. It is a very light application of asphalt usually asphalt emulsion diluted with water. It provides proper bonding between two layers of binder course and must be thin, uniformly cover the entire surface and sit very fast. So, ang role ng takot is to ensure the structural integrity of roads and pavements. It serves as a thin layers of asphalt, typically consisting of asphalt emulsion diluted with water that is applied between two layers of binder course. Next layer is uh, prime coat. It is an application of low viscous cutback bitumen to an absorbent surface like granular basis on which binder layer is placed. It provides bonding between two layers. Unlike top coat, prime coat penetrates into the layer below, plugs the voids and forms a watertight surface. So, ang essential aning prime coat nga component kay in the maintenance of the constructions or the roadways and other absorbent surfaces, it it involves the application of a low viscous cutback bitumen onto a granular base prior to the placement of binder layer. Unlike sa takot, which is primarily serves as a bonding agent, ang prime coat kay nag-step further by penetrating deeply into the underlying layer, which is nag-fill siya og voids and creating a durable and impermeable surface. Next is the surface course. It is the layer directly in contact with traffic loads and generally contains superior quality materials. In a civil engineering and road construction, the surface course plays a vital role in ensuring durability and long-term stability. It also serves as the uppermost layer of pavement structure. It directly encounters the immense forces exerted by the traffic loads. The uh, the fundamental objective is to effectively distribute these loads to underlying layers, especially the base course. Uh, by the use of the characterized superior quality materials, the surface course is carefully designed and constructed to withstand the harsh condition imposed by heavy vehicles and changing environmental factors. Typically, concrete is the preferred material for this layer due to its exceptional strength and its durability. This choice enables the surface course to effectively bear and distribute the excessive loads generated by repetitive traffic movements. The next layer is called base course. It is the layer of material immediately beneath the surface of binder course, and it provides additional load distribution and contributes to the subsurface drainage. So, ang base course is a crucial component of road construction. It serves as the layer of materials located directly below the surface of the binder course. Napod tay ginatawag na layer na sub-base course. It is the layer of material beneath the base course, and primary functions are to provide structural support and improve drainage and reduce the intrusion of fines from the subgrade in pavement structures. This layer focuses on the topic of sub-base course. So, ang essential ani nga elements kay in the construction of road and pavement structures. The sub-base course located beneath the base surface played a crucial role in providing structural support, facilitating drainage, and preventing the intrusions of fines from the subgrade. By examining the functions and the significance of sub-base course, we can gain a deeper understanding of its importance in ensuring the durability and longevity of transportation infrastructures. Lastly, last layer is called topsoil or subgrade. It is a layer of natural soil prepared to receive the stresses from the layers above. It is essential that at no time soil subgrade is overstressed. In in constructions and engineering the instructions, the importance of subgrade is it is a layer of natural soil that must bear the stresses imposed upon it. It is imperative to ensure that this soil layer is never subjected to excessive stress, as it can lead to detrimental impacts on stability and longevity of structures. The next type of pavements will be discussed by the next reporter.
Good day, everyone. My name is Michelle GENOBIAGON. Today, I'm going to continue the discussion about the types of rigid pavements. Rigid pavements are a type of pavement that is constructed using concrete slabs. They are designed to be very stiff and strong, and they are able to withstand heavy loads. Rigid pavements are typically used for applications where durability and long life are important, such as highways, airports, and industrial facilities. Components of rigid pavements. Rigid pavements are typically composed of the following layers, which is the subgrade, the natural soil that the pavement is built on. Second is the subbase, a layer of crushed stone or the gravel that is placed over the subgrade to provide a stable foundation for the pavement's slabs. Third is the pavement slabs, the concrete slabs that make up the surface of the pavement. Fourth is the joints, the space between the pavement slabs that allow for movement due to temperature changes. Next is the seals, materials that are placed in the joints to prevent water from entering the pavement structure. So, the rigid pavements has advantages. Rigid pavements have several advantages over flexible pavements, including the durability. Rigid pavements are very durable and can withstand heavy loads. Next is long life. Rigid pavements have a long lifespan of 20 to 30 years or more. Low maintenance. Rigid pavements require very little maintenance. Next is the smooth ride. Rigid pavements provide a smooth ride. So, let's proceed to the disadvantages of rigid pavements. Rigid pavements also have some disadvantages, including high initial costs. Rigid pavements are more expensive to construct than flexible pavements. Next is susceptibility to cracking. Rigid pavements are susceptible to cracking due to temperature changes and heavy loads. Next is difficult to repair. Rigid pavements can be difficult to repair, especially if the cracks are extensive. So overall, rigid pavements are valuable asset for infrastructure development. They provide a durable and long-lasting surface that can withstand heavy loads. Rigid pavements are also relatively low maintenance, making them a cost-effective choices for many applications. The example of rigid pavements are California bearing ratio test and the beam stabilimeter test. So, let's proceed to the four types of rigid pavements, which is first is jointed concrete pavements, second is jointed reinforced concrete pavements, third is a continuous reinforced concrete pavements, and fourth is the pre-stressed concrete pavements. So, jointed plain concrete pavements, GPCP, contain enough joints to control the location of all expected natural cracks. All necessary crackings occurs at joints and not elsewhere in the slabs. GPCP do not contain any steel reinforcement. However, there may be load transfer devices, which is dowel bars, at transverse joints and deformed steel bars, tie bars at longitudinal joints. The spacing between transverse joints is typically about 15 feet for slabs and 7 to 12 inches thick. Jointed concrete pavement refers to a type of pavement made up of individual slabs or panels of concrete that are separated by joints. These joints allow for controlled cracking and movement, accommodating temperature changes and preventing uncontrolled cracking. The design and construction of these joints help distribute the stresses and strains induced by traffic loads and environmental factors, contributing to the durability and performance of the concrete pavement. Now let's move to the next slide, which is the jointed reinforcement concrete pavement. Although reinforcement do not improve the structural capacity significantly, they can drastically increase the joint spacing to 10 to 30 meters. Dowel bars are required for load transfers. Reinforcements help to keep the slabs together even after cracks. Jointed reinforced concrete pavement, which is GCRP, is a type of rigid pavements that combines the principles of jointed concrete pavement with the added strength and durability provided by reinforcement. It involves the use of steel reinforcement, such as rebar or welded wire mesh, in the concrete to enhance its structural capacity. The joint in GRCP serve multiple purposes, including accommodating the natural expansion of and construction of the concrete due to temperature changes and preventing uncontrolled cracking. The inclusion of reinforcement helps mitigate the effects of tensile stresses and provide added support to the concrete, reducing the likelihood of cracks and increasing the overall longevity of the pavement. GRCP often used in high traffic areas and locations where the pavement needs to withstand heavy loads and challenging environmental conditions. The combination of jointing and reinforcement contributes to a more durable and reliable pavement structure. Next is the continuous reinforced concrete pavement. It is complete elimination of joints are achieved by reinforcement. Continuous reinforcement concrete pavement (CRCP) is a type of rigid pavement that differs from jointed pavements in that it lacks transverse joints. Instead of having regularly spaced joints to control cracking, CRCP relies on the continuous reinforcement throughout the entire length of the pavement. This reinforcement, typically in the form of steel bars, help distribute the stresses and control cracking without the need for transverse joints. CRCP is designed to minimize the occurrence of transverse cracks and is known for its long-term durability and reduced maintenance needs. The continuous reinforcement provides structural support, allowing the pavement to better to better withstand the effects of temperature changes and traffic loads. CRCP is often used in highways and the other high traffic areas where the goal is to achieve a smooth and durable pavement surface. The next slide is all about the pre-stressed concrete pavement are designed and produced to be pre-stressed to bear tensile forces caused by external loads by various live objects such as vehicles on the roads or aircraft in the airports. Pre-stressed concrete pavement involves the use of pre-stressing techniques to enhance the performance and durability of concrete pavement. In this method, high-strength steel tendons or cables are placed in the concrete before it is cast. These tendons are then tensioned to apply compressive forces to concrete before it experiences external loads. The idea of this is to create a state of compression in the concrete which counteracts the tensile stresses that occur when the pavement is subjected to loads. The pre-stressing process helps to control cracking, improve load carrying capacity, and enhance the overall performance of the pavement. Pre-stressed concrete pavement is often used in situations where a high level of structural strength and durability is required, such as bridge decks, parking structures, and other heavy-duty applications. This method can result in...
Good day, everyone. I am EUGENES GADING, and I am the last reporter of Group 5. And my topic was all about failure criteria of rigid pavements. So, what is rigid pavements? Rigid pavements, commonly made of concrete, exhibit distinctive failure criteria that impact their performance on highways. One prominent issue is reflective cracking, where existing cracks in the underlying layers propagate upward through the rigid surface. So this occurs due to the concrete inability to accommodate significant movements, especially in response to temperature variation. Another critical failure mode is joint deterioration, whereby the joint between concrete slabs weaken over time, leading to spalling or loss of load transfer capability. There are four major criteria of rigid pavements. First is the soil stabilization, second is chemical stabilization, third, lime stabilization, and fourth is ASTO design method. So, soil stabilization is a fundamental process in civil engineering aimed at improving the mechanical and chemical properties of soil to enhance its load-bearing capacity and overall stability. Various techniques are employed to achieve this goal. Mechanical stabilization involves compaction or blending with additives like lime or cement, altering the soil's physical characteristics. So soil stabilization is essential for construction projects, ensuring the longevity and performance of structure by mitigating issues related to weak or problematic soils. The choice of stabilization method depends on factors like soil type, project requirements, and environmental conditions. Next is chemical stabilization. It is a pivotal technique in civil engineering that involves the introduction of chemical additives to alter the properties of soil and enhance its engineering characteristic. Common chemical stabilizers include lime, cement, and fly ash. When mixed with the soil, these additives initiate chemical reactions that lead to improvements in strength, durability, and compressibility. For lime, it reacts with the soil to create pozzolanic reaction, forming stable compounds that increase the soil's bearing capacity and reduce its susceptibility to swelling or shrinking. And cement stabilization involves the hydration of cement particles resulting in a matrix that bends soil particles and enhance overall cohesion. Next is fly ash, and it is a byproduct of coal combustion, can chemically react with soil components to improve both its strength and long-term stability. Chemical stabilization is particularly effective in treating expansive or clayey soils, transforming them into more stable and reliable construction materials. This technique plays a crucial role in creating a solid foundation for infrastructure projects, ensuring the longevity and performance of structure built on chemically stabilized soils. The third criteria is lime stabilization. It is a prominent method in geotechnical engineering used to enhance the engineering properties of soil. This process involves the addition of lime, typically in the form of quicklime, which is also known as calcium oxide, and hydrated lime, which is the calcium hydroxide, to the soil. Upon mixing, a chemical reaction known as pozzolanic reaction occurs between lime and the siliceous or aluminosilicate particles in the soil. This reaction results in the formation of stable compounds such as calcium silicate hydrates, which significantly improve the soil's strength, reduce plasticity, and enhance its load-bearing capacity. The benefits of lime stabilization include increased durability and reduced compressibility, making the treated soil more suitable for construction projects. This method is widely employed in road construction, foundation stabilization, and other infrastructure projects to create a stable and robust subgrade and that ensure the long-term performance of structures. The last criteria is the AASTO method. AASTO means American Association of State Highway and Transportation Officials. This is a widely used approach in the United States for designing flexible pavements structures such as asphalt pavements to ensure their structural integrity under varying traffic loads and environmental conditions. This design method considers the structural response of the pavement through the use of the AASTO design equations. Key factors in the AASTO design include the traffic loadings, pavement materials, and environmental conditions. The method employs the concept of layer coefficient to characterize the structural contribution of different pavement layers, considering their stiffness and thickness. The AASTO design method emphasizes the importance of accounting for the specific condition of the project site, including soil properties and climatic influences. By utilizing empirical relationship and performance models, the AASTO design method aims to provide reliable and practical framework for designing pavements that can withstand the demands of traffic and environmental factors over their design life. There are some considerations for AASTO design method. First is the pavement performance. Next is traffic, subgrade soil properties, material of construction, environmental effects, drainage, and reliability. For pavement performance, it encompasses the ability of road surfaces to endure the demand of traffic and environmental condition while maintaining functionality and safety. It is a multidimensional concept that involves evaluating various factors such as loading bearing capacity, durability, smoothness, skid resistance, drainage, efficiency, and structural integrity. Next is the traffic. So it encompasses a complex interplay of various elements including vehicles, types, volumes, speeds, and patterns. The study of traffic in the context of highways is crucial for designing infrastructure that accommodates the diverse needs of road users while ensuring safety and efficiency. Factors influencing traffic include peak hours, congestion, traffic flow dynamics, and the impact of various transportation modes. Next is subgrade soil properties. These are fundamental considerations in the design and construction of roadways and other infrastructure projects. The subgrade refers to the natural soil or the top layer of the earth upon which the pavement structure is built. Understanding the properties of the subgrade soil is critical because it directly influences the overall performance and stability of the pavement. So key subgrade soil properties include its composition, moisture content, density, and strength. So the composition indicates the types and proportions of soil particles present, affecting factors like drainage and load-bearing capacity. The moisture content influences soil volume changes with excessively dry or wet condition, potentially leading to settlement or instability. Density reflects how closely packed the soil particles are, impacting the ability to support loads. And the strength of the subgrade soil is a crucial factor in resisting deformation under traffic loads. Then next is the materials of construction. It encompasses a diverse range of substances used in the creation of structures and infrastructure. These materials serves as the building blocks for everything from buildings and bridges to roads and dams. Common materials include the aggregates such as gravel and sand, which form the basis of concrete and asphalt mixture. Cement, a binding agent, plays a crucial role in creating durable and stable structures. Wood, steel, and aluminum are widely used for structural components, each offering unique properties and advantages. Bricks, stones, and concrete blocks are essential for masonry construction. Advanced materials like reinforced concrete and composite materials enhance structural strength and resilience. The selection of materials depends on factors such as intended purpose of the structure, environmental condition, and cost considerations. Last is the highways. Highways can significantly impact the environment, and understanding these effects is crucial for sustainable infrastructure development. Construction and operation of highways can lead to deforestation, habitat fragmentation, and disruption of ecosystems. The clearing of land for road construction can result in the loss of biodiversity and changes in local hydrological patterns. Moreover, the extraction of materials for road building contributes to resource depletion and landscape alteration. During operation, vehicles' emission from highways release pollutants into the air, leading to air quality degradation and potential health concerns for nearby communities. The impervious surfaces of roads can alter natural drainage patterns, leading to increased runoff and the potential for water pollution. Noise pollution is another environmental impact, especially in urban areas areas along busy highways. To mitigate these effects, sustainable highway particles incorporate measures like eco-friendly construction materials, wildlife corridors, stormwater management systems, and noise barriers. Environmental impact assessments and strategic planning are essential components in designing and managing highways to minimize their ecological footprint and contribute to a more sustainable and ecologically balanced transportation infrastructure. And that would be all. Thank you.